Okay, so protractors, line up the vertex of the protractor right in the middle of that circle. I then want you to mark off 30 degrees in this direction. Okay, on the edge of your protractors.
Why didn't we learn this when we first started doing trigonometry?
Okay, centre, 30 degrees, mark. Okay, so mine's there. Then with your straight edge, once you mark your 30 degree, from the centre, mark that point on the circle. There. And then on 30 degrees on your axis there, horizontally transpose that point onto 30 degrees. So horizontally. So what's sine of 30 again?
1 over 2.
Half.
I said 1 over 2 first.
But you're still wrong. Right, so remember an angle is measured clockwise, anti-clockwise about this axis, okay? So now we need to do 60. So from here, measure off 60, which should be up here somewhere. Root 3 over 2, which is approximately 0.877. So, protractor here. From here, measure it around 60 degrees. Mark that point off. Then use the origin of the circle and the point you've just marked off. Line it up and mark the point on the circumference. Then, at 60 degrees, and horizontally transpose that point you've just done on the circumference. Is going to be, I'm not going to be overly accurate because of my equipment, is going to be approximately there. Alright, 90 degrees. Okay, so that's correlating to that top point of your circle. Okay, because this is 0, that's 90 using your all student take calculus. Notes there. All stations calculus. Alright, so there's 90 degrees up there, obviously, because that's where the right angle is. Then transpose that until you get to 90. Okay, keep going around your measure of your protractor until you got all those dots in, and that'll form your sine curve. Okay. Alright, so next one, 120. So from, this is 0 here, so you're going to go around 120. Okay, mark it off. And then transpose that point on circumference to match the angle that you started with.
I made one in physics that was really cool.
Okay, keep going until all those points are done.
I had one where I marked like every 5 to, it's not a 5, I think it was 5 millimeters. Every 5 millimeters I marked the point. And it was just like,
immaculately drawn sine curve, eh? Okay, so of course, once we get past 180 degrees, alright, we're measuring in the third quadrant, and that's going to give you a negative answer because you've gone into the third quadrant. Alright, remember your all student take calculus, so between 0 and 180 degrees, the sine curve is going to be above the horizontal axis.
well, that makes sense.
Okay,
Well,
below,
wow.
sine is negative in the third and fourth quadrant, so that's why it's below, it is below the x-axis. Or you get a negative y value. Now, when you do these questions, you won't be required to do accurate sketch of this nature. Okay, so you all should be getting good, hopefully, with drawing your sine curve. Okay, a bit more freehand drawing. Right, so that's one way we can get the sine and cos curve. Pretty cool, eh? Okay, now also consider that. Which quadrant is cos positive? First and fourth. So between 0 and 90, the cos curve is going to be above the x-axis. Okay, between 270 and 360, okay, the cos curve is also going to be above the x-axis. Okay, now the second and third, cos is negative. So the cos curve is going to be below the x-axis between 180 and 270. So just that sine curve there. So it looks like everyone just about done or already done. Any suggestions on how I'm going to start this one so I get the accurate graph? I can't do it the same way as I did the sine in terms of the layout of your protractor. Any suggestions how I'm going to align the protractor so that I'm going to get my cos curve? Upside down? Really? Because that'll make it negative in both the first and second quadrant and positive in the third and fourth.
So like on the side.
Yeah, okay, so we've got to shift it 90 degrees because we want the shift to be, we had positive, positive, negative, negative, and we want now positive, negative, negative, positive. So if I shift it 90 degrees, okay, so in other words, for the cos curve, I just go in like that. And that's my starting point. Okay, so 0 from that point is going to be that top point of your circumference, okay, because the cos curve starts at 1. Okay, translate that over to 0. So, 30 degrees. Okay, so that's now your 0 up here. So that's what you're measuring anti-clockwise from there. So 30 degrees. Okay, mark it off on the circumference. It's going to go there somewhere. Right, so that's your 0 now. Okay, so 0's as you go that way. Sorry?
Are they your marks? Basically.
Pardon?
So you've got like the same points from your last, like the sine curve, they're just
Yeah. Keep going.
starting with a point.
Mm-hmm.
Yep, good. I was just about to ask the question, what did you notice? You've already noticed something. Okay, of course we're using degrees here. Alright, so don't forget we've been using radians this topic as well. Right, so obviously at 90, we're on the axis itself. Okay, 180, we're down here because you rotate 180 here. So you're at -1. And at 270, you're back to 0. And 360, when you've done the full revolution, you're back at the starting point. Okay, and then we mark off those points in between. What is cos of 60 again?
Half.
It's half, same as sine of 30. Okay, so once you've got all your points there, then draw the curve through them.
Do you want another sheet? Quickly.
Yeah, do you print off a couple of spares?
Show it. You're going to just show it. No? Why not?
Okay, who can use their mathematical words and reasoning communication skills, alright, to explain what you notice between the two curves?
How is this the opposite of sine?
The opposite. The opposite.
It. No, it's not. It's.
They have a, what's it called, where it's like a mirror image or something.
It's just moved along 9 times.
Yep.
Yeah.
So what do we call that in physics? Who doesn't do physics?
We always. Oh.
So the rest of you, what do we call that in physics?
Don't know. We haven't done it because we're.
Really?
Super busy.
Called a phase.
I do. Sound waves don't them together.
It's called a phase shift.
That sounds good.
Okay, phase shift.
Yeah, none of us did that.
Face.
Should probably.
Have you done like waves, motion?
We did.
So you they should know that then. They should have told
Very
you that.
basic though. Like here's a sheet, draw a sine curve, we're done.
Oh, but I can smell it from here.
Alright, so really, if you shift your sine curve to the left 90 degrees worth, then you're going to have the starting of your cos curve, aren't you? Okay. So that's what I want you to get out of this part of the lesson.
Oh man, there was 2 sides.
Oh,
I did both of them on
Oh.
the same.
I had 2 diagrams there. I thought you would have put 2 and 2 together and figured that out. But you were able to notice the shift on yours. Put it that
Yeah,
way.
I noticed there and I was like, wait a second. Sine.
Oh yeah, I missed the point. No, I just
It's meant to be at 360 degrees.
God, the damn spiders.